Hello, my name is Alex, and in this video we'll talk about running your reinforcement learning policy training for your robotics workloads in the cloud on demand on NVIDIA GPUs. So first of all, let's look at the containers on NVIDIA Container Registry. So we have IsaacLab, which we discussed previously in previous videos, and we're using this specific container here, version 2.1.0. And then also there's IsaacSim container, but the benefit of using IsaacLab container is that it encapsulates IsaacSim container inside. So it comes with the SIM capability by IsaacSim, as well as RL code with all of the different libraries available, such as RSLRL, Stable Baseline 3, and all the good stuff. So knowing that this is the container of our selection, we will deploy this container and we'll run this container on NVIDIA L4 GPU in the cloud. And this is going to look like this. So basically inside of the IsaacLab container, we already have everything we need. We just need to supply a definition of the submitted job. And then we're going to use this container, which is nvcr.io, NVIDIA IsaacLab 2.1.0. So this is the guidance that kind of allows us to set up the submitted job. Then in terms of the use case, we're still going after Dexter's shadow hand, and we're going to use this Isaac Repos Cube Shadow Direct v0 environment. And you can look up the list of available environments by executing a Python command, or again, this web page allows you to see what comes with IsaacLab out of the box. Then in terms of the GPU compute, so we mentioned that we're going to run this on NVIDIA L4 GPU, L4, L40, or later on we can show running this on Tesla T4, which is RTX compatible and capable of running IsaacSim headless, which is what's required for IsaacLab for SIM. So we have several options in terms of where those GPUs are available. So if you look at the AWS GPU compute, you can see that G4, EC2 G4 instances have Tesla T4. We also mentioned in previous videos NVIDIA A10s, which is available with the G5 series. L4 is are available with the G6, and then L40S available G6E. This is on AWS. In terms of the GCP, so we have different types of GPUs also available here. So for example, G2 gives you L4, and then N1 will give you, let's say, T4. Then in terms of Azure compute, so there are several families of VMs with the GPUs available. So there's NC family and NV family, which we can focus on just briefly. So we had some experience, and we showed previously running IsaacSim and IsaacLab headless in Azure on Azure GPU compute using NVIDIA A10s, which is available as a part of NVIDIA's A10 V5 series, as well as like if you're looking at Tesla T4 GPU, then it's possibly it's NC AS T4 V3 series. So this is in terms of the GPU compute and where we will be able to run these kinds of workloads on demand. Now let's take a look at actually how to execute this, review the results, and see how we run IsaacLab and IsaacSim for reinforcement learning policy training for Dexter's shadow hand on demand in the cloud. So first of all, let's look at the already completed run. And in this case, after running reinforcement learning policy training for Dexter's shadow hand on NVIDIA L4 GPU, after 3-4 hours of execution, on 10,000 iterations, with iteration time roughly being 1.5 plus seconds. We got the result. So this is the log of running this kind of training. And then as you can see that we got everything executed, and 10,000 iterations for dexterous shadow hand. Now let's peek inside of the container and see what's available and kind of show you the resulting policy, as well as what's available inside of the IsaacLab container, which encapsulates everything we need for the successful reinforcement learning policy training. So I'm gonna look up what's available. So we can see the folder structure here. The command which executed inside of that container when this container ran was this. So essentially we're running IsaacLab script with submitting a script for reinforcement learning for training of a specific task, which is Isaac repos cube shadow direct v0 headless mode. And the only thing I did is, instead of stable baselines 3, I used RSL-RL. So this is what executed when the container launched. There's a one caveat relative to the Vulkan drivers, and IsaacSim uses Omniverse Kit, which relies on Vulkan for GPU accelerated rendering and physics. And then you have to avoid potential conflict of drivers with Vulkan. So there's a specific syntax that I used in submitting the job to avoid this kind of conflict. Once this is done, it's a couple of lines of code in the job definition. Once this is done, basically this command is all you need. And then let's look at the results. So for RSL-RL or stable baselines 3, we're going to have our results and resultant policy put in the logs folder. So here's the RSL-RL subfolder. Then we have shadow hand. We have the subfolder which has everything, different checkpoints, as well as the final model is going to be model_9999.pt. And then if I want to look up, let's say, some more information about this, I can do ls-lh, and then this shows me that it's 12 megabytes size of a file for my PT PyTorch trained model for reinforcement learning policy for shadow hand. So this is how we see what was produced. And now let's launch a new job from scratch, and you'll see how the container will come to life and the training will begin. All right, so we just kicked off the new training run for dexterous shadow hand. So right now the container is loading all of the necessary prerequisites, and it's using CUDA device. It's loading the configuration for the shadow hand environment. And shortly, the training iterations will commence. Here we go. So we have loaded the environment successfully, and we started iterating with the reinforcement learning policy training. So this may continue for a couple of hours until you receive the result, and then you can stash your result in the proper place for further experiment tracking and continuation of your robotics workflow experimentation. Thank you.